Look at the diagram below. Then answer the following question. What type of angle is the angle highlighted in the green below? So it looks like two anteaters going after an ant right over here. And this anteater is going straight down, or at least on my screen it looks like it's going straight down. And this anteater is going straight to the left. And so it looks like this one's going straight down, this one's going straight to the left. It looks like this is a right angle or a 90-degree angle. And so if I had to pick between any of these, it looks most like a right angle. It looks like this is exactly going down and this is going exactly to the left, that this is a 90-degree angle here. If this was an acute angle, then the angle between them would be smaller. So maybe this top one would be coming in from this direction right over here. If it was obtuse, this angle would be larger. So let's check our answer and try to do a few more of these. Which of the angles labeled in the diagram below are acute angles? So just as a reminder, an acute angle is less than 90 degrees. So let's see. A and C both look larger than 90 degrees, but B and D both look less than 90 degrees. So B, I'll go with B and D are the acute angles here. Let's do another one of these. What type of angle is the angle highlighted in green below? Well, this angle is less than 90 degrees. If it was equal to 90 degrees, this thing would come out like this. So this is clearly less than 90 degrees. This is an acute angle. Let me just do one more. This is a lot of fun. Select a symbol from the drop-down menu to complete the following statement. Then answer the question below. Angle A is less than 90 degrees. Less than 90 degrees. What type of angle is angle A? So angle A, it's less than 90 degrees. So an angle less than 90 degrees is an acute angle. If it was exactly 90 degrees, it would be a right angle. If it was larger than 90 degrees, it would be an obtuse angle. So I will go with acute angle. We got it right. Put the vertex of the angle at point A. So let me do that. Make one of the rays go through point B. Make the other ray go through one of the other points to make an acute angle. So an acute angle is an angle less than 90 degrees. So we can make one of these rays go through point B. And then we have to pick where to put the other ray to make it go through one of the other points. And we have to be very careful here because we have to look at this arc that shows which angle the tool is actually measuring. Because we might be tempted to do something like this, thinking that, hey, maybe this is the angle that we're thinking about, but the tool thinks we're referring to this outer angle right over here, this larger, huge angle. This angle right over here is well over 180 degrees. So we have to pay attention to this arc to make sure that the tool is looking at the same angle that we are. So once again, we want an acute angle. So this right over here looks like an acute angle. It looks like it is less than 90 degrees. And we have to be very careful that we go exactly through that point. So that looks about right. This is an acute angle because its measure is less than 90 degrees. Let's do a few more of these. Make an obtuse angle using the black points. Choose one of the points as the vertex and make the rays go through the other 2 points. The angle should also be less than 180 degrees. So you could think of it several ways. You could just try to pick that point, but then when you go through these other 2 points, this right over here is an acute angle. This is less than 90. This is less than 90 degrees. You could do something like this, where now when I switch the rays, the tool is now thinking about this angle, not this kind of this outer angle right over here, but this is larger than 180 degrees, so this also doesn't apply. So we really picked the wrong point for the vertex. If you just move this out of the way and eyeball it, it looks like you get the largest angle that's less than 180 degrees if you put the vertex right over here. So let me do that. Put the vertex right over there, and now it looks like I have constructed a 180 degree angle. And we have to be very careful that we go right through those points because otherwise it might mark us wrong. So that looks pretty good. That's an obtuse angle because its measure is greater than 90 degrees. Let's do one more of these. So another obtuse angle using the points, same general idea. Same general idea. So that would be an exactly 180 degree angle. And there we go. And this is an obtuse angle because it is greater than 90 degrees. Match these angles with their measures. There should be one angle in each category. We have 30 degrees, 60 degrees, 90 degrees, and 180 degrees. So there's a few that are very easy to spot out. This angle right over here, it makes a complete line. So this is clearly 180 degrees. So this one's 180 degrees. The other one that might jump out at you is this one right over here. This is clearly a right angle or a 90-degree angle right over here. So this is 90 degrees. And so we have to think which of these is 30 and which is 60 degrees. Well, just by comparing it that way, you know that the one that opens out more is going to be 60 degrees, and the one that opens out less is going to be 30 degrees. And you can see that the opening here is half the size of the opening right over here. So it makes sense that this is 30, this is 60. And it also makes sense that this angle is 1/3 the measure of this angle right over here. That this is 90 degrees. And then if you were to double this, then this part of the angle would go all the way out, and you would get to the 180 degrees. So let's check our answer, make sure we actually got this one right. Let's do one more just for fun. Which of these angles has a measure of 60 degrees? So there's a couple that we can immediately rule out. This angle here is clearly more than 90 degrees. It's an obtuse angle. This angle here is 180 degrees. So we're going to have to pick between these two. And we can assume that these are all at scale. So if we know that a right angle would have this line straight up and down, this looks like it's 2/3 of the way there. So I would go with this one right over there. Now you might say, well, what about this one? Well, this one looks like it's about 1/3 of a right angle. If we were to do 2/3, then 3/3, it looks like we would get to a right angle. So this one looks much closer to 30 degrees. So which of these angles has a measure of 60? That one right over there. You can immediately rule out that one, and then these take a little bit closer inspection. So this one's 180 degrees. The other one that might jump out at you is this one right over here. This is clearly a right angle, or a 90 degree. That this angle is 1/3 the measure. Let's say I have an angle ABC, and it looks something like this. So its vertex is going to be at B. The vertex is at B. Maybe A sits right over here, and C sits right over there. And then also, let's say that we have another angle called DAB. Actually, let me call it DBA. DBA. I want to have the vertex once again at B. So let's say it looks like this. So this right over here is our point D. That is our point D. And let's say that we know that the measure of angle DBA, let's say that we know that that is equal to 40 degrees. So this angle right over here, its measure is equal to 40 degrees. And let's say that we know that the measure of angle ABC is equal to 50 degrees. Is equal to 50 degrees. So there's a bunch of interesting things happening here. The first interesting thing that you might realize is that both of these angles share a side. If you view these as rays, they could be lines, line segments, or rays, but if you view them as rays, they both share this ray BA. And when you have two angles like this that share the same side, these are called adjacent angles, because the word adjacent literally means next to, adjacent. These are adjacent, they are adjacent angles. Now there's something else that you might notice that's interesting here. We know that the measure of angle DBA is 40 degrees and the measure of angle ABC is 50 degrees. And you might be able to guess what the measure of angle DBC is. Measure of angle DBC. If we drew a protractor over here, I'm not going to draw it, it'll make my drawing all messy, but if, well, maybe I'll draw it really fast. If you had a protractor right over here, clearly this is opening up to 50 degrees, then this is going another 40 degrees. So if you wanted to say what the measure of angle DBC is, it would essentially be the sum of 40 degrees and 50 degrees. And let me delete all of this stuff right here to keep things clean. So the measure of angle DBC would be equal to 90 degrees, and we already know that 90 degrees is a special angle. This is a right angle. This is a right angle. There's also a word for two angles whose sum add up to 90 degrees, and that is complementary. So we can also say that angles DBA and angles ABC are complementary. And that is because their measures add up to 90 degrees. So the measure of angle DBA plus the measure of angle ABC is equal to 90 degrees. They form a right angle when you add them up. And just as another point of terminology that's kind of related to right angles, when you have a right angle, when a right angle is formed, the two rays that form the right angle, or the two lines that form that right angle, or the two line segments that form that right angle are called perpendicular. So because we know that measure of angle DBC is 90 degrees, or that angle DBC is a right angle, this tells us, so this tells us that DB, if I called them, maybe I could say the line segment DB is perpendicular to line segment BC. Or we could say ray BD is, instead of using the word perpendicular, there's sometimes this symbol right here, which really just shows two perpendicular lines. BD is perpendicular to BC. So all of these are true statements here, and these come out of the fact that the angle formed between DB and BC, that is a 90-degree angle. Now, we have other words when our two angles add up to other things. So let's say, for example, I have one angle over here. Let's say I have one angle over here that is, let's just call this angle, so let me put some letters here so we can specify it. So let's say this is X, Y, and Z. And let's say that the measure of angle XYZ is equal to 60 degrees. And let's say that you have another angle that looks like this. You have another angle that looks like this, and I'll call this, let's say maybe a MNO. And let's say that the measure of angle MNO is 120 degrees. So if you were to add the two measures of these, so let me write this down. The measure of angle MNO plus the measure of angle XYZ is equal to this is going to be equal to 120 degrees plus 60 degrees, which is equal to 180 degrees. So if you add these two things up, you essentially are able to go all halfway around the circle, or you could go, throughout the entire half circle or semicircle for a protractor. And when you have two angles that add up to 180 degrees, we call them supplementary. I know it's a little hard to remember sometimes. 90 degrees is complementary. They're just complementing each other. And then if you add up to 180 degrees, you have supplementary. You have supplementary angles. Supplementary angles. And if you have two supplementary angles that are adjacent, so that they share a common side, so let me draw that over here. So let's say you have one angle that looks like this, and that you have another angle. So let me put some letters here again, and I'll start reusing letters. So let's say that this is A, B, C, and you have another angle that looks like this. You have another angle that looks like this. That looks like this. No, I already used C. That looks like this. Notice, and let's say once again, let's say that this is 50 degrees, and let's say that this right over here is 130 degrees. Clearly, angle DBA plus angle ABC, if you add them together, you get 130 degrees plus 50 degrees, which is 180 degrees. So they are supplementary. So let me write that down. Angle DBA, and angle ABC are supplementary. They add up to 180 degrees. But they are also adjacent angles. They are also adjacent. And because they're supplementary and they're adjacent, if you look at the broader angle, the angle used from the sides that they don't have in common, if you look at angle DBC, this is going to be essentially a straight line, which we can call a straight angle. So I introduced you to a bunch of words here, and now I think we have all of the tools we need, to start doing some interesting proofs. And just to review here, we talked about adjacent angles, or I guess any angles that add up to 90 degrees are considered to be complementary. This is adding up to 90 degrees. If they happen to be adjacent, then the two outside sides will form a right angle. When you have a right angle, the two sides of a right angle are considered to be perpendicular. And then if you have two angles that add up to 180 degrees, they're considered supplementary. And then if they happen to be adjacent, they will form a straight angle. Or another way, if you have a straight angle and you have one of the angles, the other angle is going to be supplementary to it. They're going to add up to 180 degrees. So I'll leave you there.